a few years, like 5 years after Shannon published his seminal paper on communications, another guy, Weaver, he published another paper where he was saying, okay, we have also other levels of communication. We have a semantic layer. So the semantic layer, the goal is to transmit some semantic information, right? So it's not just symbols, but what the symbol means, right? And so he said we have this kind of knowledge base that is shared with the transmitter and the receiver, and then you can decode some semantics. And that semantics can be misunderstood as well, right? So you can say, okay, I transmit an image of a bottle, and maybe I want to mean something or to obtain some result that could be misunderstood. So you have another level which is called effectiveness, right? So you said these 3 levels, but then for like 70 years, people really didn't care about this in communication. So yeah, video conferencing machine actually try to look at this, and the idea is actually pretty simple. So we had some motivation already why we want to do coding for machines. I tried to give you a motivation that is a bit more high level in the sense of principle, theoretical principle. And the reason is pretty intuitive. If you take a classical video transmission pipeline, right, you have source X, like your images or videos you want to transmit. You have an encoder, you have bit stream Y, then you decode this bit stream, right, and you get some approximation of the original video, right? So, and in traditional coding, we try to minimize this error in the reconstruction using SNR or other metrics. And when you want to do some task, for example, you want to put this in the cloud, right? So some detection or tracking or things like that, you will take this video that has been received and you want to compute some task, like detection, right? So if you look at this chain, you can easily model this like a Markov chain, right? And then you know there is something in information theory that is called data processing inequality that tells you that essentially every time that you do processing, you cannot increase the information. You can only remove some information, right? And this is pretty intuitive. I'll show you an example just after. But the idea is that due to the data processing inequality, when you do video calling for a machine, you can expect that the bit rate you need to perform a task is actually much less, in general it's lower than the bit rate you need to reconstruct the full video, right? So this is the basic principle that is underlying the video calling for machines. That's why we we want to code for machines. So said like that, it seems simple, but actually this is the main, it's all about this, how you remove the information that is not relevant for this specific task, right? So how you actually optimize the encoding for a machine. So this is an example that, just to show you what I mean, right? So imagine that you have this image from some video surveillance system, and you want to put this into an algorithm that needs to count the number of vehicles, right? So if you do that, you realize that actually to count the number of vehicles, you don't really need to have information about what is outside the road, right? So this is not relevant, okay? So this is intuitive for us, and so there is also like theoretical concept behind this, which is the information bottleneck. But this is very, as many things in information theory, is very abstract. So, and this depends on the task, by the way. And so the whole problem of video coding for a machine at the end of the day is how to design a real information bottleneck, how to optimize this for real signals for specific tasks, right? So I wanted to also point out that this is, again, not new for us in our community. We have been doing this for a specific kind of task, which is human vision, right? We have always been doing perceptual optimization of code. This has been done for decades. And that's a specific case, right? So at the end of the day, we are doing that. So an example is the concept of JND, the just noticeable distortion. So when, there are works dating, even if you take the classical matrices used for JPEG compression, they have been designed based on this concept, right? Concept of masking, essentially on the concept that there is a lot of information in images or videos that our visual system cannot perceive. So you don't care about coding it. right? So this is the concept of perception we have in classical image processing. As you probably most of you know, nowadays, if you go to other communities like computer vision, they talk about perception, and they mean machine perception. So, we can imagine that we could look for similar concepts like just noticeable distortion from machines. Actually, there are some papers already doing that. But we can also shift some concepts from quality of experience of humans. We go to something that is quality from machine or utility. Right? So this is called utility in some context. And so this is another perspective that you have on the video coding from machine domain. And another thing that I believe it's interesting to look at, it's something that maybe some of you have seen. It's called the perception distortion trade-off. Okay?